Welcome back everyone to Learning by Teaching. We're in Calculus 1 and today we're going to solve problem 30 of chapter 3.1 of the Thomas Calculus book, okay? So the question says, at t seconds after liftoff, the height of a rocket is 3t square feet. How fast is the rocket climbing 10 seconds after liftoff? Okay, so basically they're telling us that we have the function of the height of this rocket and the function is equal to 3t squared. So we're going to put that our function in terms of t is equal to 3t squared. Alright, now they're asking us how fast, basically at what velocity or speed is this rocket climbing. So they give us the time, but we don't know what's the velocity equation, right? What's the function, basically. That's what I'm trying to say. So what we're going to do is that in order to find the velocity of this rocket, we have to do the derivative. And in this chapter, we're working with the definition of the derivative, where the derivative of this function is going to be equal to the limit as h approaches 0 of my function evaluated at t plus h time minus my function evaluated at t. All these divided by h. Okay? Now, if we take a look at this, well, we have the function evaluated at t time is equal to 3t squared, but we don't know what f to the t plus h time is. So what we can say from here is that, okay, but f of t plus h, we can just find it out by changing all our t's for t plus h. So in this case, I'm going to change my t for a t plus h, and we square it. Now that we have our function at t plus h, we can just plug it into our limit. So we're saying basically that we have that the limit as h approaches 0 of, so first f of t plus h, which is equal to this in here, so we got 3t plus h squared minus 3t squared, all divided by h. Now we have our limit. The problem is that we cannot replace our h equal to 0. The problem is that we have an h in our denominator, and if we put a 0 in our denominator, then we cannot calculate it, and this is basically just an error, right? So what we're going to do is that let's try to solve this algebraically in order to get rid of this h at our denominator. What we're going to do is we're going to first start by foiling this h square, this parenthesis is square, I'm sorry, the t plus h squared. So we're going to have 3 multiplied by t squared plus 2 times th plus h squared. If at this point you're wondering how I found this, basically I just used the a plus b squared is going to be just a squared plus 2 times ab plus b squared. If you are not comfortable using this, what you can do is just using a plus b multiplied by a plus b and just FOIL out each single one, okay? Okay, now that we know this, we're going to do minus 3t squared and we're going to divide it by h. Okay, now that we have that, what we're going to do is FOIL again back in here. This 3, we're going to multiply it by all our terms in our parentheses. So we'll have 3t squared plus 3 times 2 will give me 6th plus 3 times h squared minus 3t squared, all divided by h. Let's not forget that we have our limit. So let me move in here. I forgot to write that we're in a limit as h approaches 0. Okay, so we have that the limit as h approaches 0. And what do we have? Well, the next step is to combine by terms. So when we reach this step in here, we got all our terms in the basic like the simplest way that we can, and it's all expanded out. Now that we have them like this, what we're going to do is that we're going to combine by terms. So first we got 3t squared minus 3t squared. Basically these two guys cancel out. Now I think that's all that we can do for this one. So what we're going to do is we're going to do 6th plus 3h squared all divided by h. If we realize all our terms in the bottom and also the most important, our numerator, involve h. So what we can do is that we can cancel those h out. How can we cancel? Well, we can realize that we're going to cancel 1 in here, 1 in here, and 1 in here, right? This is just going to be left as 1. Or what we can do, and what I like to do, is that I like to visualize it, and then I like to do a common factor and the numerator of h. So we'll have a common factor of 6t plus 3h all divided by h. And then in here, when I can visualize that I can cancel h and h, so let's do that. We're going to cancel. Then that's when I realize that I can cancel, and I will have still my limit as h approaches 0 of 6t plus 3h. Okay, now that our basically limit doesn't have a denominator of h at the bottom, what we can do is that we're going to replace every single h for it to be equal to 0. Now we can expand out, like break the limit. Okay, so we're going to have 6t plus 3 times 0. Then this 3 times 0 will give me 0, and that basically tells me that my derivative of this function is just equal to 6t. Okay, so we found the equation, the speed equation for this rocket. Now the question says, how fast is the rock climbing 10 seconds after the liftoff? So we need to say that we want to find the speed or the climb off of this when time is equal to 10 seconds. So what we're going to do is we're going to replace our t for 10, and we will have 6 times 10. That will give me an equal of 60 feet per second. Okay, and this for our speed at 10 seconds should be our answer, our 60 feet per second. If you guys liked the video, please push the like button, subscribe, and I'll see you guys in the next one.